For this question, we have a block of mass 8 kilograms which is placed on a rough plane and is inclined at 30 degrees to the horizontal. The coefficient of friction between the block and the plane is a half, and then a horizontal force P is applied to the block. So for part 1, all we need to do is mark on all of the external forces that are on the plane. It is sufficient at this stage to get all of the marks just to mark on the friction acting up the plane, the normal reaction perpendicular to the plane, and the weight under gravity of the block. That will get us the marks for marking on the external forces. At this stage we don't actually need to resolve the forces. So once we've got our diagram, we can just set that out of the way, and then we can look at finding P. So that's what part 2 asks us to do, find P. Because the block is on the point of slipping down the plane, we know then that it's in equilibrium, so the forces acting up the plane are equal to the forces acting down the plane. So if we look at the forces acting parallel to the plane, we can say that Fr, so friction, plus P cosine 30, which we have acting up the plane, is equal to 8g sine 30, which is acting down the plane. So if we hold on to that for now, and then if we look at the forces that are acting perpendicular to the plane, we can say that R is equal to P sine 30 plus 8g cosine 30. So now we've got a value for R. We're able to take that value for R and put that into our formula for F max. So if you can remember then, F max is equal to mu R. We know our mu is a half. So our F max is equal to a half upon P sine 30 plus 8g cosine 30. And then that is our formula for F max. We can now then put that back in to our equation up here. So we call this equation 1. Then equation 1 is going to become a half of P sine 30 plus 8g cosine 30 plus P cosine 30 equals 8g sine 30. Once we've got that, then we want to start expanding all of this out to actually find what P is, and then we will have our answer. So if we then move all of the terms that don't have a P to the other side, and all of the terms that do have a P to this side, so we're going to have a half P sine 30 plus P cosine 30 equals 8g sine 30 minus our 4g cosine 30, and that 4g comes from 8g divided by 2. Since we've got two terms with P in it on the left hand side, if we factorise out the P, we'll have P upon half sine 30 plus cosine 30 is equal then to our right hand side, so 8g sine 30 minus 4g cosine 30, which then allows us to say that P is equal to 8g sine 30 minus 4g cosine 30, all divided by a half sine 30 plus cosine 30, which then will let P come out as 4.71 newtons, and that's the three significant figures. If we break down the marks for this question, there will be 2 marks for marking on all the external forces in the diagram. There's then 3 marks for resolving parallel to the plane, 2 marks for resolving perpendicular to the plane to get R. There was then 3 marks for getting down to our second line, and then the additional one last mark was for getting P equals 4.71 newtons.